Welcome to this video. I'll be talking about k-means clustering today. K-means clustering is basically just a way of sorting data points in the data set into different groups. And so breaking it down a little bit, the k in k-means clustering is just the number of groups. And with k-means clustering, the number of groups is a predetermined value. So there are ways to determine what number of groups would be best, but that's outside the scope of this video. So just know that it's a predetermined number. So that's the number of groups, and then means is in the name because you use the mean to determine the clusters. And I'll show you a little bit more what I mean by that as I walk through this example. So this is a very simple example, but I think it will get the point across of what is happening in the background when we are performing a k-means clustering analysis. So I just have some random data points on this two-dimensional chart, and we want to sort them into groups. So we'll say that for this one, our k equals 2. So we want two groups. And the way that computer programs will do this, normally we don't do it by hand. The way that it would do this is it'll pick two random data points. So I'm going to change my color to red. So let's say it selects this one randomly and this one randomly, right? Okay, and then it will look at every single data point in the data set and decide which one is closer to it than the other data points, than the other randomly selected data points. So, for example, this one is obviously closer, this one's obviously closer, so is this one. This one looks like it might be closer to this one. So essentially, you're going to choose all the data points that are closest to the randomly selected one, and those are going to be part of the cluster. All right, so now we have two clusters. From here, is this the most accurate cluster? Probably not. So what you do from here is you take the mean of that cluster. So it's not necessarily going to be a data point, but it's somewhere right in the middle. So we'll say right here, there's the mean, and then this one, because of this outlier, it's probably going to be somewhere about here. And then you recalculate the clusters based on which data points are closest to the means, and that's where the means parts of the name comes in. So let's say we recalculated it, found the closest data points, and for the sake of the example, let's say it ended up grabbing these two data points, and then this one now turned out to look like this. So you see that the cluster slightly changed. We're going to repeat this again until the clusters do not change. So pick green, find our new mean of this newest cluster, so the one in yellow, and let's just say it's right here. Probably didn't change too much. We probably got bumped over to the right a little bit. But let's say after calculating this cluster, you realize that it didn't change from the first one. Did not mean to include that data point. But essentially, once it doesn't change, then you know that you have the most accurate clustering based on the first two random data points that you selected. Okay, and you're not quite done yet. So you choose so then you calculate the variance, which is the distance from the mean, which in this case would be the final mean, which would be this green one, be our third one. And you total the variance for each group. So let's say this group 1, let's just say the variance was 20, and for group 2, the variance was 21. Okay, so we have our first round of clusters. Then we do that all over again. We repeat the same exact steps and calculate the total variance. So let's say we did this all over again, clustering it, and then for the third round, for the second round, we got a variance of 18 for the first cluster, and 19 for the second one. So you see that this cluster calculation is smaller variance. You repeat that over and over and over, or the computer does, until you find the clusters as the total variance that's the smallest. And that's the cluster that you want to decide, that you want to go with. From there, you can use your clusters to perform various methods of analysis. And that right there is k-means clustering.